This is problem 10.8a from page 550 from your homework from last night. This is the long way problem, and I wanted to take you through the steps so you can check your answers. This is a problem where we're supposed to find a 90% confidence interval for the mean yield mu. Since we know what sigma is in this problem, it's appropriate to use the one sample z interval. For our parameter, we're trying to find the mean yield mu, so our parameter in this problem is our population value mu, and mu is the mean yield. You can see in the bottom it talks about mean yield. That's how much corn is produced. Our population is based off of our sample. Our sample is 15 plots, that represented by these 15 points here, so the population is going to be all plots. And in step 1, we have addressed the procedure, one sample z interval, parameter mu, which is the mean yield, and our population, which is all plots. This is step 1. Step 2, we check our conditions. There are two conditions to check. The first is that our data comes from a random sample. I don't see anything about random sample in this problem, so we're going to say it does not say a random sample was taken. So we proceed with caution. For our second condition, the first thing we'll check to see if it says anything about our data coming from a normal population. I don't see anything about the term normality here, so we have to move on to our second part. The second thing we could check is that our data comes from a large sample size. It doesn't. It's only 15. We need 30 for a large sample size. So what we're stuck doing here is graphing our data, and hopefully our data, when we graph it, ends up being approximately symmetric or normal. To graph this data, we enter the data into your calculator into a list. I have my data in list 1 in my calculator. Then we're going to go to the stat plot command, second y equals. I'm going to turn on one of my plots. We're going to make sure that the normal probability plot is selected, along with list 1, or your data list, X for your data axis, and then our mark. To get a nice looking graph, we'll do zoom 9, which is zoom stat, and that should ensure that your graph shows up nicely on your screen. So here's our graph, and what we're going to do in step 2 is we're going to copy a picture of this graph down, and then we'll make a little comment in just a moment. So here's our normal probability plot. You'll notice that it's fairly linear. It's not bad. It goes through the middle here. There's a slight curve to it, so it's not perfect, but it's good enough for our purposes. So we write the normal probability plot is approximately linear, so it is not unreasonable to assume the population is normally distributed. So that takes care of our conditions. Step 3, carry out the procedure. Now we're actually going to work out the confidence interval formula. Our formula for this problem is x bar plus or minus z star times sigma over the square root of n. To find x bar, we're going to go back to your calculator. We're going to go to stat calc, one variable stats, and we're going to pick out the mean here, which is 123.8. That's your sample mean. Z star is a value that you get from the back of the book. We've dealt with 90% confidence already. The z star value for 90% confidence is 1.645. Sigma in this problem comes from the data that you see here. It's 10. We are not going to use the sigma that appears on your calculator. Don't use 11.84. We're going to use the sigma that appears down there, which is 10. And for n, we're going to work with our sample size. In this problem, our sample size was equal to 15. So we're going to multiply this by 10 over the square root of 15. When you actually crunch this out, and you can use your calculator to actually do this, you should get a couple values, a small value and a large value. The smaller value goes first inside the parentheses, that's 119.55. The larger number goes second, that's 128.05. Now we can interpret our results, and here we say we are, list your confidence level, 90% confident that mu, which is the mean yield, is between the two numbers you came up with, 119.55 and 128.05. If there's units, include them. Here your units are bushels per acre.